Hi lads, today we're looking at area and volume. We're looking at this particular question here. As you can see, I've already made a start on it. We're going to go through it and hopefully make sense of it, and then you're going to have a go at a few questions from me again. So if we look here at this question, we'll read it. We have AB, and AB is inside in the square brackets, and what that means here is that I have a length from A to B. So I have a length from A to B. And CD, so CD, which is another line, are each divided into 5 equal parts. So we can see that here, 1, 2, 3, 4, 5, of length 10 meters. 2 of the end points, okay, end points, are joined by a line segment, okay, and the quadrilateral AEFD is shaded in. So AEFD, again, AEFD. So we have this unusual shape here in front of us. The question here asks us to find the area of the shaded region AEFD. Give your answers in meters squared, because that's a unit for area. And it says here it might help you to break the shaded region up into a rectangle and a triangle. So you can see here what I've done already. I have broken this up into a rectangle and a triangle. Okay. I've shaded in what I need to work out, because I need to get the area of this section here, the rectangle, and the area of this section here, the triangle. I need to add them up to get the total area. And once I've done that much, then I will have discovered the total area of the shaded region. Okay, so you can see here what we need to do here is we need to get the area. So that we use our formula for area of a rectangle or a square, which is length by width. And it's 25 multiplied by 20, because the total length of this line here is 10 plus 10, which is 20. So 25 by 20, okay, again, you can use a calculator to confirm, but you should get for that 500. Now, that brings us on then to the triangle. The triangle here is equal to half the base by the perpendicular height. Okay, now for this one, again, we need to, I suppose, add in a little bit of detail here for us. Straight away, anyway, I would say that this here, this length here from this endpoint to this endpoint is going to be 20, 10 plus 10. And also, we should be able to figure out that the length here, or you might call it the base, is 25. So 25 from here to here. So therefore, if we work out the area of this triangle, it's going to be half of the base, which is 25, multiplied by 20. You work that out in a calculator and you should get a value here of 250. Okay, now again, that is meters squared. Now, you might be tempted to finish at this stage, but remember what you're asked to do. It says, find the area of the shaded region. So we want the entire shaded region. So therefore, what we have to do to finish the question is total area equals 500 meters squared plus 250 meters squared. You get equals 750 meters squared. Okay, and that is the answer for that question, the shaded region. Okay, next question. This one relies on the theorem of Pythagoras. Now, for Pythagoras, we have a general formula, and that general formula is hypotenuse squared equals opposite squared plus the adjacent squared. Okay, now we have a triangle here. It says use the theorem of Pythagoras to show that EF, so if we go back to our triangle, we have EF was the diagonal. Okay, so we have a triangle like this. I'm after drawing it wrong. Okay, we have a triangle like this. We know that this is 20, so from the previous part, this is 20 and this is 25, and we're asked here to work out the length here of this part, EF. Okay, now I should be able to recognize that this is a right angle. So therefore, this is going to be the length of the hypotenuse here. Okay, so the hypotenuse is an unknown in this question. So therefore, to do this question, what we could do is we could call this x. Okay, we're going to fill in for the hypotenuse x squared. Okay, so the hypotenuse squared, x squared, equals the opposite. So the opposite in this question could be 20, so 20 squared, plus the adjacent squared could be 25 squared. So what I need to do here is I need to get my values here using my calculator. So 20 squared, and I get 400, plus 25 squared equals 625. So x squared is equal to that. So therefore, 400 plus 625 equals 1025. So x squared is equal to that. I don't really care what x squared is worth, but I do want x, the value of that length. So x is equal to the square root of 1025. So square root equals square root of 1025 equals, I get a weird value here, which is 5 square root 41. I change that to 32. So x equals 32, and that's my value.